Hi students, in this week's videos, we're going to do circles. Basically, there are two different ways of expressing circles, the standard form and the general form. We will also be using some of the concepts we have learned in coordinate geometry, such as m1 times m2 equals to -1, parallel lines have the same gradient, finding equations of a straight line, perpendicular bisectors, things like that. So you have forgotten some of the concepts. This is a good time to revise them. And we'll be also learning some new concepts that are needed in this chapter. Circles definitely it's not an easy chapter to manage. So do have some motivations to keep it going on, such as having some energetic drink or some chocolates around so that you can stay till the end. Right, let's start off by deriving the standard form of equations of a circle. And since we're managing the topics and circles, we'll be drawing many circles, right? So you have to bear with it. And let's draw another circle. Right, and what do you think the circle, what do you think any circles will have? What are some of the qualities that a circle have? Right, a circle definitely has a center. Right, we're going to call it A, and it has X coordinate A and Y coordinates B. And of course, you can have many points also on the circumference of the circle. We're just going to identify only one particular point where we're going to call it P. And this point P has X coordinate X and Y coordinates Y. All right, so let's go on to identify what does the X coordinates of A means. It means it is a distance from point, is a distance of point A from the Y-axis. I forgot. Yes, that's important. All right, we need to join a line from A to P that will give us the radius of the circle, right? A circle must have a radius to determine how big or how small it is. And why do I draw a right angle triangle? We will talk about it later, right? Okay, so this is what I meant just now, that the distance of point A from the y-axis will gives you the x coordinate, and the distance from the x-axis will gives you the y coordinates. But let's do a comparison first, a comparison between point A and point P. Right, so the distance, the A is actually the distance of point A from the y-axis. So x is the distance of point P from the y-axis, right? All right, so when you take x minus A, where does it goes? Correct, that's the reason why I draw a right angle triangle there. Okay, so when you take x minus A, it goes there. And we're going to do the same for the y coordinates. So B is the distance of point A from the x-axis, and y is the distance from the x-axis also for point P. And when I take y minus B, where do you think the distance goes to? Correct, it goes there. Okay, and what does a right angle triangle remind you of? What are some of the concepts you have learned in regards with a right angle triangle? Yes, Pythagoras theorem. This is exactly what we're going to do. We're going to apply Pythagoras theorem. Okay, where your a squared is just bracket x minus a close bracket squared, and plus your b squared, which is your bracket y minus b close bracket squared, equals to your c squared, which is your r squared. And basically, we just got it. This is the standard form of an equations of any circle, where the radius is r units, and with the center of the circle, it's a comma b. Right, let's put what we have just learned into practice. Let's look at question 1. So question 1, it's direct applications of the standard form equation. You're given a circles with center 0, 1 and radius 4 units. And you asked to find the equations of a circle in standard form. Because they are another form that we have mentioned, I had mentioned it earlier, that's the general form. But let's learn the standard form first. So how do we go about doing it? Yes, let's write down the formula. So this formula is quite easy to remember. It's derived from the Pythagoras theorem, which is a squared plus b squared equals to c squared. Right, so A and B represent the center. So let's write down the information that's given, 0, 1. So 0, you can sub in the values of A to be 0, the values of B to be 1, and the values of R to be 4 units. Right, and this is what you get. And we need to simplify it. Do not leave your answer as x to the minus 0. Simplify it as x to the power of 2. And of course, you can just leave bracket y minus 1 to the power of 2 as it is. There's no need to expand it because you are asked to find the equations in the standard form, and that is the standard form. All right, so basically, this is just how we can just do direct applications of the formula. Let's look at part B. Part B is slightly challenging because now the circle you're not given. Now you're not given the radius. You're given the center, but not given the radius. But you're given an additional information, and that is the circle actually touches the x-axis. So what do you mean by the circle touching the x-axis? Right, so I've just drawn a diagram for you. For this chapter, I think it is good. It is really a good practice to draw the diagram. You don't need to draw very accurately, but at least have a visual idea of how it looks like. So we have a circle there where it's touching the x-axis. And if you look at the diagram, you will see that the radius of the circle, it's basically just the value of your y coordinates in positive form. Correct. Okay, so the radius is just 2 units. And with this information, again, we can substitute into the formula, where you can substitute the values of A to be 3, the values of B to be -2, and the values of R to be 2 units. And then this is what you get. Right, when you substitute into your y minus b, just be careful, it's y minus bracket -b, because the values for your b is -2. So that in the end, when you simplify it, you turn out to be y plus 2. Right, so this is how you do it. Right, let's try another 2 more questions. In questions 1c, similarly, we are given the center, which is -3, 4. However, we are not given the radius of the circle, but we are told that the circle actually touched the y-axis. So what do we understand by circle touching the y-axis? So this is how the diagram will look like. Right, so from the diagram, it's quite clear that the radius of the circle is actually the positive value of your x-coordinate. And in this case here, it's 3 units. Right, so with all this information, we can just substitute into the formula. Right, the only things to take note of is because the values for A is -3, so ensure that you bracket it so that your negative times a negative will give you a positive here. All right, so that is part C. How about part D? Part D, it says that the circle touches both axes. So what it means is that your x and the y axis are both tangents to the circle. Right, so what it means that the distance of the center from the x-axis is equals to the distance of the center from the y-axis, which is equals to 2 units. And that it also means that the radius is equals to 2 units. So with this information, you can just substitute into the formula again. Right, and again, a reminder that because the values of your A is -2, you would have to bracket it. So the negative times negative will give you a positive here. So this is how you are able to find the standard form of the equations of any circles given the center and the radius. Right. Remember what I mentioned earlier, that there are actually 2 different representations of the equations of a circle. You can actually represent it in the standard form, but we can also represent it in the general form. So how do we get the general form? Right, basically the general form is actually derived from the standard form. So we start off by having the standard form, and then we do some manipulation to the standard form to get the general form. So how do we go about doing it? So we start off by expanding the standard form as follows. So using the algebraic identities, right? So we expand your bracket x minus a close bracket to the power of 2, and this is what we get for both terms there, also for the bracket y minus b close bracket to the power of 2. Right, so what is the next thing we do? Yes, we rearrange the terms as follows. Right, so what we have done here is we just rearrange it as in that we put x squared together with my y squared to form x squared plus y squared, followed by negative 2xa, followed by negative 2yb, and your a squared plus b squared. R squared, just bring it from the right hand side to the left hand side. And then the next thing is that we're going to reassign these terms. What do you mean by reassigning terms? Let's take a look. Yes, we're going to let negative 2xa equals to 2gx and the negative 2yb. So it's just a re-representation. We're going to represent the negative 2xa equals to 2gx. Negative 2yb equals to 2fy. So here I introduce a new terms called g and f. And of course, your a squared plus b squared minus r squared. I'm going to introduce a new term and represent it by the letter c. Right, so with all this new representation, how do you think it will look like? Yes, it will look like x squared plus y squared minus, plus 2gx, because we've replaced the negative 2xa by 2gx, so become plus 2gx. And we've replaced the negative 2yb plus 2fy, so become plus 2fy, and plus, of course, c equals to 0. So with this new general form, I need to find the new center, and I also need to find the radius. So what do you think the center will be? So we have to go back to the earlier reassignment, where we have negative 2xa equals to 2gx. From there, yes, if you divide negative 2 on both sides, divide negative 2x on both sides, you end up getting a equals to negative g. And likewise, for your negative 2yb equals to 2fy, you divide by negative 2y on both sides. You get b equals to f. B equals to negative f. And we're going to make r the subject here. And if you substitute your a, because your a is negative g, so a squared will just be negative g times negative g, give you g squared. And likewise for b squared will be negative f times another negative f, gives you f squared minus c. Right. So if you were to recall that the center for your standard form, is a comma b. So if I'm going to represent a with negative g, then the center now become negative g, negative f for the general form. So if we're using the general form of the equations, then the center will become negative g, negative f, and then the radius will be this. Right, so besides knowing the standard form of the equations of a circle and in general form, there are some other concepts that we need to know, some other concepts that is not in this topic, that is from other topics that we've learned earlier on, that we will very much need to apply in this chapter on circles. So what are they? Yes, for a lot of questions on circle, in the problems, you'll be told that a certain line is a tangent to the circle. Right, so tangent to the circle means that one of the concepts that we need to know is this tangent is actually perpendicular to the radius of the circle. Right, so tangent perpendicular to the radius is important concepts for finding the equations of a tangent line. Right, sometimes also the questions will involve your quadratic inequalities. In this case here, your tangent line and your radius will just intersect at one point here. So it means it has two real and repeated roots. So sometimes we may have to employ the concepts of b squared minus 4ac equals to 0. Right, so what other concepts that's involved? A lot will be using the angle properties of circles. Circles theorems. One of it is if you have a quad and the perpendicular bisector of the chord. Perpendicular meaning the bisector and the chord forms a 90 degrees. And it is bisector means this distance here is the same as this distance here. Right, so this perpendicular bisector of the chord will pass through the center of the circle. This concept is very useful for finding intersection point, for finding the center of the circle. Right. And sometimes also we will see problem sums that involve us to apply the concepts of tangent from external points. Right, yes, where the two lines colored in blue are actually equal in length. Right. So these are the concepts may be needed in solving problem sums in this chapter, circles. Right, there's one more concept that's very important, that it's if you have a tangent line, right, you will have a normal line. And what is a normal line? A normal line basically is just your perpendicular line to the tangent line, right? And these two lines are perpendicular to each other, and the normal line will always pass through the center of your circle. Right, so when the two lines are perpendicular to each other, what is the concept that is involved here? Yes, it is when we need to apply m1 times m2 equals to -1. Right, so these are the additional concepts that you have to keep them in mind when you're solving problems in this chapter. Right, with all the concepts in mind, let's try another questions. This one is rather challenging. Right, so we have a circle that passes through 2 points, 2, 3 and -1, 6. And then the center actually lies on a line 2x plus 5y equals -1. And you ask to find the coordinates of the center of the circle. Right, like what I've mentioned earlier, it is best to have a visual representation. So this is how it looks like. We have a circle. We have 2 points there. One of them is -1, 6. One is 2, 3. And we have a center. Of course, a circle will have a center. And this center actually passes through this line 2x plus 5y equals to -1. All right, I'm going to let the center be A, B. Okay, so if you were to recall the concepts that we have learned earlier on, right, to find the centers of a circle, which concepts can we apply? Yes, the concepts of the perpendicular bisector of the chord. Because if you were to combine if you were to join a line connecting the point -1, 6 and 2, 3, that will form a chord. That is a chord. And then we have the perpendicular bisector of the chord will pass through the center of the circle. All right, I'm missing a D here. Okay, right. So from there, the important concept is the center of the circle is actually the intersection point of your perpendicular bisector of the chord and the line 2x plus 5y equals to -1. All right. So now the important thing is that I will need to find the equations of the perpendicular bisector of the chord, because I will need the equations to solve it simultaneously with my 2x plus 5y equals to -1 to find the intersection point. Right. So how do we go about finding the perpendicular bisector of the chord? We have to find the gradients, right? So to find the gradients of your perpendicular bisector of the chord, let's start off by finding the gradients of the chord, which is your y2 minus y1 over x2 minus x1, which gives you -1. And because your chord and your perpendicular bisector are perpendicular to each other, right? So the gradient of your perpendicular bisector will be -1 divided by -1, which gives you 1. And applying the very useful formula, y minus y1 equals to gradient bracket x minus x1, well, your x1, y1 is just, okay, the x1, y1, it's a point that lies on the perpendicular bisector. And the point has to be the midpoint of the chord. Which is half bracket 9 over 2. And substitute that point into your equations. That's how we find the equations of your perpendicular bisector of the chord to be y equals to x plus 4. And we're going to solve it simultaneously with your 2x plus 5y equals to -1. Let's do some algebraic manipulation. And you'll get x equals to -3. And then with x equals to -3, substitute into your equations 1. And you can get the y coordinates to be 1. So therefore, the center of the circle is -3, 1. All right, so this question actually involved the concepts we've mentioned earlier on, that the perpendicular bisector of the chord passes through the center of the circle. Right, so we have found the center of the circle to be -3, 1. We are given 2 points, -1, 6, 2, 3 on the circle. Right, so I've just drawn the diagram for you. So the radius of the circle, this is the radius of the circle. This is also another radius of the circle. So you can either use -1/6, the distance of -1/6 from the center to find the radius, or you can actually use this point. You will get the same value. Right, so that means you have to apply the distance formula, which is your x1 minus x2 close bracket squared plus y1 minus y2 close bracket squared. So supposing I'm going to use this point instead, 2, 3. So your x1 will be 2 minus away -3 plus 3 minus 1 squared. And if you were to work this out, that will be 25 plus 4 and gives you square root 29, which is the same answer as what you have obtained here. Okay, so that's how we find the radius of the circle. So to find the equations of a circle, it's easy now because we already know the center to be -3, 1 and the radius to be square root 29. So with all this information, you can just substitute into the formula. Right, and that's how you arrive at the standard form of the equations of the circle. All right, you can just leave it as it is because the questions did not require any form of the circle. If the questions did not ask for any form of the circle, you can just leave it as in the standard form. So just to watch out for having to bracket -3 and also to square your square root 29. Square root 29 gives you 29. Right, let's look at another questions. In these questions here, we are told that the positive x and y axis are tangents to a circle, and this circle is called circle C. What do you mean by the positive x and y axis? Right, so if I'm going to draw the Cartesian plane for you, this will represent your positive x-axis, This will be your negative x-axis. This one is your positive y-axis, and this is your negative y-axis. So to have positive x and y-axis means your diagram must be drawn in the first quadrant, which is what I've shown you on the diagram. And from the diagram, it's quite clear that the center of the circle will have the same x and y coordinates. I let the center of the circle be called a comma a. You can use other variables, but from there we can deduce that the center of the circle have the same x and y coordinates. So that is the answer for part I. Alright, so for part 2 and 3, we're given a point 9, 8 that lies on the circle, and then a tangent line that passes through this point 9, 8, and this tangent line is called line T. So there are two things we need to do here is to find the center of the circle and also the equations of this line T. So let's start off by identifying where is 9, 8. Right, and then after that draw a tangent line. Yes, and this line is called line T. Right. So if I were to draw a line joining from this point 9, 8 to the center, you will see that this is the radius of the circle, right? And because your y-axis is a tangent to the circle, it touches the circle at only one point here, right? And if from that point, if I were to draw a line that join to the center of the circle, this line here is also my radius. And from the diagram, we can see that that is actually your x coordinate value, which is a. So in other words, the radius of this circle is a units. Right, and this is what I'm going to use to find the radius of the circle. I'm going to use the distance formula, all right, use the distance formula to find this length and then equate it to a. So the distance formula is the square root bracket x1 minus x1 minus x1 squared plus y1 minus y2 squared. Then that gives you a, and then you square both sides to remove your square root sign, and then you expand what's inside your square root. Right, so by simplifying it, you will get a quadratic equation where you can just factorize it to find two values of a, and one of them is rejected because the center of your circle actually lies below the point 9, 8. That means the your y coordinates of your center has to be smaller than 8. Right, smaller than 8. So it makes sense to have a equals to 29 to be rejected. Okay, I also need to confess that my diagram is not exactly very accurate because you see that the x coordinate is 5, right? So the center has to be smaller than 9. So my diagram is not very accurate. So if you were to draw, okay, later on I'll show you a more accurate diagram. All right, so from there, we can find the center to be 5, 5. And then the radius is 5 units. And from there, you can just substitute into your standard form to get the equation. Right, so a more accurate diagram will be this. I think it's okay because sometimes it is not possible to draw it to be very accurately because you do not actually, like for example here, you don't know what is the center of the circle, right? So now we know that it's 5, 5. So that means my tangent line, if this is my 5, 5, then my tangent line will have to be here. This point will have to be 9, 8. Okay. Right, so now we know that the center of the circle is 5, 5, and then we know this point is 9, comma 8. Now we can have a more accurate representations of how the diagram will look like. Okay, right. So what we are told that the next part is to find the equations of the line T. Line T is a tangent line to the circle at 9, 8. So to find equations of a tangent, what are the two things we need? We need to know the gradient. We also need one particular point, which I'm going to use 9, 8 because 9, 8 actually lies on the line T. But first thing first, we have to find the gradients of line L first. Okay, which is y2 minus y1 over x2 minus x1 gives you 3/4. And because the tangent line is perpendicular to your radius is line L, so the gradient of your tangent line T will be -1 divided by 3/4, that gives you -4/3. And you substitute that into your y minus y1 equals to m bracket x minus x1, and you get equations of a tangent line to be negative y equals to -4/3 x plus 20. So it makes sense because if you look at the answer, you get the gradient of the tangent line is a negative value. So in this case here, the diagram is more accurate because the diagram we've just drawn gives you a -4/3 for the gradient of the line. Right, so the past few questions we've done are just dealing with the standard form of an equations of the circle. So the next few questions will be managing the general form. So if you look at the questions that are given, the equations of the circle is x squared plus y squared plus 8x minus 24y plus 96 equals to 0. And that actually is the representations of the general form. Okay, right. And we are told that there's a normal line, and this normal line it's at a particular point R, and the equations of the normal line is 3y plus 4x equals to k. And part 1 we asked to find the constant k. Right, so if you to recall the other concepts that we have learned earlier on, right, one of them, it's the normal line. It's a line that passes through the center of the circle, and it's perpendicular to your tangent line. In other words, every tangent line will have a normal line, right? So we start off by having a tangent line, and every tangent line will have a normal line. So in this case here, this normal line will pass through the center of the circle, and is given to be 3y plus 4x equals to k. All right. Okay, so from the general form of from the general equations of your circle, from there we're going to derive the center and also the radius. So we're going to do some assignment here. That means we're going to assign 8x equals to 2gx. Yes, compare it with the general form that's highlighted in green for you. Right, so we compare 8x equals to 2gx. From there, you can get g equals to 4. Compare to fy equals to -24y. You get f equals to -12. And we can find the radius, right, which turned out to be square root 8. So with this value, we can find the center of the circle to be -g, -f, and that will be -4, 12. Radius equals to square root 8. Okay. Right. So there's an important concept. I've also mentioned it earlier, that your normal line actually passes through the center of your circle. The normal line actually passes through the center of the circle. So in other words, the center of the circle actually lies on your normal line. So that's an important concept because I can actually substitute x equals to -4 and y equals to 12 into the equations of a normal line to find the unknown k. right, which work out to be 20. So there are two things here. First of all, you need to understand, or three things. First of all, the normal line will pass through the center of the circle. That means the center of the circle actually lies on the normal line, and then it is perpendicular. The normal line is perpendicular to a tangent line. So every tangent line will have a normal line. And also we need to know how to use general form to find the center and radius of the circle. All right, let's look at part 2. So, okay, before we do part 2, I seriously have to warn you, there's a lot of algebraic manipulations in part 2. So if you're kind of feeling a bit tired now, after going through so many questions, maybe you need to have some, maybe you need to have an energetic drink or a chocolate before we attempt to do part 2. All right, so to do part 2, we need to identify two specific points. One point is point R. So R is actually the point where the normal meets the x-axis. The normal to the circle at R meets the x-axis. All right. Okay, it's a bit confusing. Never mind. Let's identify where is point S first. Point S is easier to identify because point S is just the point on the normal line and it meets the x-axis. So that is point S, where your y-coordinate is 0. So point R basically is just, it's just the intersection point of your normal line and the tangent line. It's a point on the circle, and it also lies on the normal line. Okay, so let's try to find point S first. Point S is easier to be found because it lies on the normal line. So we just let y coordinate equals to 0. Okay, so we found point S to be 5, 0. Point R, it's a bit difficult to find. If we know the equations of a tangent line, that's quite easy because you just solve them simultaneously, right? But the big problem here is I do not know the equations of a tangent line, and I can't find it because the point R, it's the intersection point, and I need the point R to find the equations of a tangent line, and I don't have it. So the only way that I can find point R is to use the equations of the circle instead. So when the circle intersect the line, the normal line, that is where R is. So point R is actually the intersection point of the circle and the normal line. Okay, so this is where I said it's very algebraic, challenging. Right. Okay. Right. So from the equations of your normal line, you can make x a subject, which is 20 minus 3y over 4. Then you substitute into your equations of the circle. Okay. All right. So this part here, you have to be a bit more careful to manipulate it. You basically expand the numerator, expand the denominator. Remember to square 4 also to get 16. Right. And then this part here, you will just take 8 times 1/4. It's 8 over 1. So it's 8 divided by 4 gives you 2. All right. And then what I've done here, the next step is to multiply every term with 16 to make it a non-fraction. So this whole chunk of thing times 16, the 16 will be gone. Y squared times 16 give you 16y squared. 2 times 16 times 20 will give you 640. 2 times 16 times 3y will give you negative 96y, negative 96y. Okay, and so on and so forth. Okay, this one times 16, this one times 16. 0 times 16, of course, will give you 0. And then you simplify it to get a quadratic equations where you can factorize it to find two values of y. Okay, and of course, we reject y equals to 18.4. Right, maybe you can think about why do you reject that point? Because if you look at the diagram, it's quite clearly that your point R, it's below the center of the circle. The y-coordinates of the center of the circle is 12. So it cannot be more than 12. So therefore, the y-coordinates of point R is 5.6. And with that, you can substitute into your equation 1 to get the x-coordinate, which is 0.8. So therefore, the coordinates for point R is 0 0.8, 5.6, and we are not done yet because we are asked to find the length of RS. So this 5 marks is very, very difficult to earn. So to find the length of RS, we use the distance formula. X1 minus x2 squared plus y1 minus y2 squared. Alright, square root it to get 7 units. Okay, so that is the plus point because the answer come out to be an integer. Okay, right. Right, let's do the next question. This one is easier in the sense that you're given the general form of the equations of the circle and you ask to find the coordinates of the center and the radius of the circle. So that is quite easy. You just need to compare the general form, compare the equations of the circle with the general form. All right, and do some assignment like 2gx is equals to 6x. Then from there you can find the values for g, and 2fy is equals to negative 4y. You can find f to be negative 2, and then you can find the radius, which is equals to 5 units. So this part here is easy. So the center is negative g negative f. Remember, it's negative g negative f. So that gives you negative 3, 2. Radius is 5 units. So this 3 marks is quite easily earned. So for part 2, you asked to show that the equations of a tangent to the circle at point P is blah, blah, blah. This part is also quite easy. Basically, you just need to have a circle and then a tangent line at this point, negative 7, 1. Okay, so to find the equations of a tangent, we need the gradient, right? And we need 1 point, and you're given already the point P. So we just need to find the gradient. So to find the, before we can find the gradient of a tangent line, you have to find the gradients of the radius, the line that join from P to the center, which I'm going to call it L. So I just need to find gradient of L, which is a y2 minus y1 over x2 minus x1, which is 3/4. And your radius and your tangent line are perpendicular to each other. So the gradient of a tangent line will be negative 1 divided by 3/4. This one is perpendicular to each other. Okay, so it gives you negative 4 over 3. Substitute into your y minus y1 equals to gradient bracket x minus x1. This is a very useful formula. Okay, and from there you can just get the equations to be y equals to negative 4 x minus 31 over 3, and do not leave the answer as such because you are supposed to answer to the question asked, and the answer is supposed to be expressed in the form. So we will have to multiply by 3 throughout the equations, and then bring everything to the left hand side, and finally confirm that yes, that is what you're asked to show. Okay, so this question 6 marks is quite easy to earn. So sometimes depends on how lucky you are. Some years the questions are quite easy. Some years the questions, you know, like the one we did just now, it can be quite challenging. Okay, so apparently we are not done yet. Okay, so this question is 12 marks, for goodness sake, 12 marks. So we've already earned the first 6 marks. Let's look at the next 6 marks. So the next 6 marks is that you have a point Q and a point Q, and this point Q lies on the circle. It's the same distance from the y-axis at point P. Right, so previously we have point P, which is negative 7, negative 1, right? So the distance from the y-axis, the particular distance is the same as the distance from Q. So I'm going to use diagram. A lot of times you have to use diagram to give you a visual representation, right? So same distance means it's the one highlighted in pink for you. Right, so roughly the point Q is there lah. All right, and then we have a tangent line. So you see that we have 2 tangent line. Can you see we have 2 tangent line? So there's one concept we have learned earlier on where you have a 2 tangent line. Do you recall what are the concepts involved there? If you have forgotten, just go back to the earlier slide to revise on that. Okay, so what are we asked to find in part 3? Find the equations of the tangent to the circle at Q. So basically, we just need to find the equations of this line. Okay, this is the equations that we need to find. So we need to know the gradient. Right, we need to know the gradient. Okay, so the one highlighted for you in yellow is your radius, right? And the one highlighted, the one that I labeled L is also the radius. So these two values are the same, right? Yes, that is an important concept. Because the distance of your point P from the y-axis is the same as the distance of your point Q from the y-axis. So that means basically your point Q is vertically above your point P. Your Q is vertically above point P. So they have the same x coordinate. So I can let the coordinates of point Q to be negative 7, y. So y is the one I do not know. Okay, but they have the same x coordinate. So I can just use the distance formula to find the radius, because in part I, I've already found the radius, or part 2, part I think part I, radius to be 5 units, right? So the one I highlighted for you, this one. So many things I've highlighted for you, so which one? This one. This is your radius, right? So your point Q is negative 7, y, right? So I can use the distance formula, right? X1, which is negative 7 minus 3 squared plus y1 minus 2 square root it. That is your distance formula, equals to radius, which is 5 units, right? So you square both sides. And from there, you can have two values of y. So again, it makes sense to reject y to be negative 1 because the point Q is vertically above point P. So therefore, your y coordinates of point Q has to be 5. Okay, so from there, we are still not done yet. We just managed to find point Q only. And then after that, we need to find the gradient. Right, the gradient of the radius line, not the gradient of the radius. Radius has no gradient. The radius of the gradient of the radius line. And then after that, I can find the gradients of your tangent line at point Q, which is negative 1 divided by negative 3/4. And from there, I find the equations of a tangent line. My goodness, so this 4 points is not easy also. All right. And then for part 4, my goodness, your tangents at P and tangent at Q intersect at point R. So where is point R? Yes, that is your point R. Right, so how do you find point R? So basically, point R is the intersection point of your tangent line at Q, also the tangent line at P. So we need to solve these two equations simultaneously. Okay, so substitute 2 into 1. So more algebra. And you work out x to be negative 37/4, and I hate this kind of value. But you must remember, it's possible, in any exam, it's possible to have values of x and y not to be an integer. So in this case here, it's a fraction, negative 7/4. After finding it, you can substitute into equation 2 to find your y coordinates. Turn out to be a nice number that's 2. Not nice number, every number is nice. A whole number that's 2. So therefore, the coordinates of r, it's negative 37/4, 2. All right. It looks like questions on circles are harder than questions on coordinate geometry. Right, so we come to the last questions. So bear with it for a while, and after you complete it, you will have a great sense of satisfaction. I promise you, because I'm about to feel the satisfaction too. Right, so we have a circle. There are basically the two circles there. We start off by having circle C1. So circle C1 has equation x squared plus y squared plus 4x minus 6y equals to 36. So that is the general form. So from there, you just compare with the general form to find your center and your radius. So this part is quite easily done. Right, you just reassign 2gx equals to 4x. You get g equals to 2. 2fy equals to negative 6y. You get f equals to negative 3. Right, and then radius is square root g squared plus f squared minus c. Your c is negative 36. Right. If you're wondering how you get negative 36, you have to minus 36 on both sides to make your right hand side equals to 0. Okay. Right, so from there you can find the center of your C1 to be negative g negative f, that's negative 2, 3, radius 7 units. So that's part I. So part 2, you have another circle called C2. So for C2, we have to draw the diagram because there are more things. You have a point A and then another point B, and AB is the diameter, and then you have a tangent line at point B. So we have more things to manage. So let's draw the diagram. Yep, okay. Right, so you asked to find the equations for diameter AB. Okay, so from the diagram, you can see that your AB is actually perpendicular to your tangent line, because half of your AB is your radius. If your radius is perpendicular to your tangent line, then of course AB is perpendicular to a tangent line, right? Basically, I think your AB is a normal line. So to find the equations of your AB, you need the gradient, right? But we don't know what's point B, right? So we can only get it from your tangent line. So the tangent line gradient is 4/3, and then your gradient of your AB will be -1 divided by 4/3. Okay, and we can use point A because point A lies on the line AB to find the equations of your AB. Okay, and then what's next? Oh, we found the equations of diameter AB. Yeah, that's great. So the next thing is to find the coordinates B, and from the diagram you see that B is the intersection point of your diameter and the tangent line. So we have to solve these two equations simultaneously. So a lot of algebra here, so you need to be strong in the algebra. Okay, if you get the answer wrong, you have to practice a few times, okay? Don't just look at my answer. To be quite honest, I'm not being what do you call that? You will say maybe I'm not humble, but I feel that when I explain it, it's quite clear to you. But it does not mean that you know how to do it. You only know how to do it only when you really try it out on your own without looking at my solutions, and within probably 10 minutes, not take 2 hours to do it. So that is not helping you also, all right? So in order to really know how to do it, is to do it on your own and within 10 minutes to get the answer correct. So therefore, we found the coordinates of B to be 3, -1. Okay, so we're not done yet. Now we still have part 3 and 4 to do. So let's meet at the next slide. Right, so let's look at part 3. Part 3 is relatively easy. We have already found the coordinates of point B. Right, so from there, using the same diagram, from there it's quite easy to find the center of this circle C2. The center is basically the midpoint of the diameter AB. Right, so you can use the formula to find. Yes, let's write down the value we found for point B, which is 3, -1. So the x coordinates of the center of C2 will be x1 plus x2 divided by 2. Y coordinate will be y1 plus, it's plus, okay, y1 plus y2 divided by 2. So the center of a circle is -1, 2. And then the next thing is to find radius. Find radius is relatively easy. You can just use point A or point B, use the distance formula, right? And you will find that both, if you use point A, you will get 5 units. Use point B, you also get 5 units. So that's part 3. So part 4, we have a point 4,6, and we need to determine whether this 4,6, this particular point, whether it lies inside C1 or C2. So what's the concept here? How do you determine whether a certain point lies inside, outside, or on the circle? Yeah, basically you just need to calculate the distance of the point from the center of the circle. If the distance is less than the radius, then it's inside. If the distance is equal to the radius, then it's on the circumference of the circle. If the distance is more than the radius, then it's outside law. So this is what we need to do. Okay, let's start off by finding the distance from the center of C1. And you find that it's 6.71, which is less than the radius of C1. But we cannot conclude that it lies in C1, right? Because it may be some intersecting circle and then it lies in both circles. So we have to go on to find the distance from C2. We can't just stop here. Okay, and then to find the distance, we come out to be 6.40, which is more than the radius of C2. Only then we can confirm that this point lies inside C1. Okay, so this ends the whole video on the assignments on circles. Okay, you should give yourself a big clap or 3 claps, okay, for surviving it through. Well done.